2 today. So with 12-2, it is, what is it? Oh yeah, arithmetic. Arithmetic. Sequences. And series. That is what we're doing today. So what makes something arithmetic sequence or a series is it has to be linear. Okay? How did we decide if something was linear? What pattern did we see? What the freaking hell? Just messing around while I'm teaching? Yeah, big fella. Okay. Anyway, so when we're doing arithmetic sequences, this is when we see like 1, 3, 5, 7, 9. We continue to add a certain number. But isn't subtracting the same thing as addition? Okay, I could say add a negative number, right? So it's either adding or subtracting the same number over and over and over again. That is how you know if it's arithmetic. Okay? Now, when it is arithmetic, that means it is linear. Arithmetic means it is linear. Okay? So, our slope would be that constant increase. First off, what does linear mean? It means it has the same slope, right? What is the basic equation for the same slope? Or not same slope, but same equation of a line. Y equals mx plus b. They don't write it this fashion. This is how they like it. A sub n equals our common difference times n plus a sub 0. Okay, basically it's the same thing as y equals mx plus b though. Okay, they just have a different word. So in our case, what is our common difference? 2. What is our a sub 0? Do we know? Well, this is 1. So what would I just do? Go backwards the pattern, wouldn't I? Yes? So notice we're continually adding 2. So if I went back a negative 2, that'd be negative 1, and that would be my a sub 0. Does everybody see that? So then that would be negative 1, or 2n minus 1. That is our generic form for this specific sequence. Sir? Yes. They might also have another way. How many guys remember doing point slope form? Okay, that was a little bit, we even did it in 1010. Point slope, it was like this. Y minus y1 equals x. Excuse me. Let me erase that first. Boop. Slope times x minus x1. Well, they have the same thing. Okay, where it would be, in this case, it's a sub n equals a sub 1 plus our difference. And then this would be n minus n sub, what would it be? N minus 1, that's what it is. Boop. Boop, boop, boop. That's another way to do it. Notice we just had that term 1, 3, 5, 7, and so on. Let's figure this out. What's our a sub 1? Who is our a sub 1? 1. So a sub n equals 1 plus what's our difference? Difference is 2. N minus 1. If I distributed that through, 1 plus 2n minus 2, which is 2n minus 1, which is the same thing we got last time, right? So you guys can choose either fashion. Each of them have their own reason on why I would use one over the other. Okay? By the way, I'm just going to tell you guys flat out, it depends on you. Well, you guys don't have books, huh? Never mind. Cancel that. Did anybody have a book from last semester that they still have? You guys had books last semester, right? So if any of you guys have books by last semester, you need to bring them in or you guys will be getting a $150 fine coming up. So just be aware of that. It's a big one. Okay, so this is called the nth term, which we just found last time too, right? But this one is a linear equation, so that makes it arithmetic. Okay, there's other things that they might ask you to do in this. We could have different terms, meaning they could have different styles. Let's see this one. So let's say they have a sub n is 1, comma, negative 4, comma, negative 9, comma, negative 14, and so on. Okay, I want you to find the nth term, okay, or the a sub n. We have two different ways. Remember, we just did this way, d sub n plus a sub 0, or you could go a sub 1 plus your difference times n minus 1. Both of them will get you there. Go ahead and try it on your own. I want to meet somebody. That was so good, wasn't it? You guys just loved that, didn't you? I should be on your guys' choir tour, Chandra. You guys didn't take me to damn Boston. What the hell? Am I not that fun? It's because I say, damn it. The beaver. Somebody's getting mad. So I'm like, I was talking about, you know, like a cement or a wooded barrier. So somebody drew me a picture if I could point. And then, oh my hell, it just depends on where the comma is. Oh my, there's hell. Right? Maybe it's not really that funny, but I thought it was great. You're dying back there today. Where's your coffee? That's why you're dying. Damn dogs. Did you get it? Did you do it? What'd you get? Plus 6. How many of you guys got exactly what Deanna got? Yay, because that's right. Here we go. Let's just show you how. She went ahead and saw, oh, I'm decreasing by 5. Did you do the top or the bottom one? So you did negative 5n. And then you said, oh, I got to go backwards. So this is subtracting 5. So if I want to go backwards, I got to add 5, right? So that's where the 6 came in. And notice, basically. Let's show it the other way, though. A sub 1 is 1. Plus our difference is negative 5 times n minus 1. Okay? So that would be negative 5n plus 5. 1 plus 5 is 6. And then our negative 5n. Okay, still got the same one. Any questions there? She thinks she's a famous celloist that she does screw this. I don't need no mathematics. By the way, you will also be getting sooner or later a graduation clearance form. I will not sign your graduation clearance form until May 15th. That's the earliest I'll sign it after I figure out your test. That'd be awesome, even better actually. That's the first time I would sign it. Hopefully it would be the 16th for the fact of the matter, then that's the day that I can actually have your legit grade. Did we talk about how on the final on the 15th you guys need to be scheduled for 2 hours? You might miss a little bit of your first class. Second class, 15. So kind of put that in your notes. Don't be late that day, please. And I can't see her, but she's over there somewhere. Okay, so here's another example. Another example says, okay, let's go ahead and say the 11th term is 52, and the 19th term is 92. We're already telling you it's an arithmetic sequence, though. Okay, it's already an arithmetic sequence. So that means we are continually adding the same amount. Yes, ma'am. You are more than welcome. Okay, how am I going to find, because both of my equations uses a sub 1 or a sub 0, doesn't it? Do I really want to find my difference and then go back 11 steps to figure out a sub 1 or a sub 0? So this is where the point slope one can come in. Instead of saying a sub n equals a sub 1, I could put a sub 11 here. Plus difference of n, instead of being minus 1, what do you guys think I'm going to put in? Minus 11. Because the first time this was a sub 1 and this was 1, right? Does that make sense to everybody? So therefore, if this was 2, then I'd put a 2. Or if this was 19, I'd put a 19. Does that make sense? So we're a little bit there because I could go ahead and say, okay, a sub n equals my 11th term, which is 52, plus my difference, I still don't know that yet, n minus 11. How am I going to find that difference? How did you guys ever find slope with 2 points? Say again. What do you subtract? Can you remember the equation? If you recall, slope was y2 minus y1, because that's your rise, right? The y values is the rise, over x2 minus x1, which is your run. You guys remember doing slope that way? You could also kind of think of it as if this is 1152 and this is 1992. That was a good year, actually. You guys weren't even a twinkle in your parents' eyes yet. Good times. How much did we rise if we went from 52 to 92? 40. How much did we run if we went from 11 to 19? 8. And remember, slope is rise over run. So 40 divided by 8 is 5. So I just replace this with a 5. Don't make me pull out. We're pulling out it today. You guys are requiring it. Oh, it's loaded. That's right. Don't make me get on this. Okay, so that's 52 plus 5n minus 55. So what do we end up getting? Our a sub n is 5n minus 3. That is our generic case. I can clean up. Yes, I'm ready. That was horrible. I expected you to do better. I've seen kids throw these things like better than I almost shoot them. Okay. Should we do another one of those? Yeah. Let's say A sub 48, yeah, is 19. A sub 20 is, what the heck do I want to do? Negative 17. I'm going to push pause and let you try. Slope equation again, or in this case we call it our common difference, right? Is basically y2 minus y1 over x2 minus x1. So this is basically representing your y2, y1, and then this is representing your x2. Does that make sense? And the other one's x1. Now, could I go vice versa? Could I call this x2 and this x1 and still get the same? Okay, answer your question? Because I'm behind the desk today. So I just substituted in, went ahead. Once again, I could do it this way as well. Negative 17 minus 19 over 20 minus 48. It would still give me the same result because this time it'd be negative 36 over nuts. I didn't make it very nice. I was trying to make it nice. Oh well. That's why you're in this class. What can I reduce those both down to? 9/7. So D is 9/7. Not very fun, but it's okay. So here we go. A sub n equals A sub 11. Who was our A sub 11? Or excuse me, A sub, was it 11? A sub 20 or 48. I don't care. Which one do you guys want to do? Let's do the top one. So A sub 48. What the heck? I am, okay, A sub 48, which was what? I'm struggling. Okay, let's start again. Deep breath, everybody. Here's the point. I had A sub 48 as what again? 19. Okay. So here we go. A sub 48 plus our difference times n minus 48. So our A sub 48 was 19 plus 9/7 n. 9 times 48, that's 360 plus 72. So come on, come on, come on. 432. Is that, guys? Hurry, help me out. My brain, as you can tell. Was it? Nine times negative 48? You did the 20. $430. No, you're okay. If you did the 20, it's okay. Okay. Now 19, I got to get a common denominator. 19 is 133 divided by 7 plus 9/7 n. Now there's lots of fractions in here. I didn't mean to make it so fractiony. I apologize for my wrongdoing to you and your family. So here's what we got. 9/7 n minus 299 over 7. Did you get the same result? There you go. Okay. Hi. Nope. You can choose either one. Would you like me to do it the other way? Yep, I'll do it the other way just for kicks and giggles. I'm a nice guy. So that's negative 17 plus 9/7. And then what term was the negative 17? The 20th? So n minus 20. So therefore that's negative 17 plus 9/7 n minus 1/87. So I need to get a common denominator. So that's negative 17 times 9. That's a 9. Carry the 63. 153 sevenths. Well, that doesn't make sense. Oh, dingleberry, I times by 9, not 7. Oh, silly rabbit. Times by 7, that's a 7. 119? Is that what it was? I think that's right. So what you got, buckwheat? Ben? And then notice 9/7 n minus 1, 299 sevenths. See how I got the same result? Okay, so that's finding the generic term. Okay? All right, they usually have story problems with these. A story problem like this could be, if you look in our auditorium, in the middle section, okay? Our middle section starts with a sub 1 is 11 rows. The second row, 11 seats. The second row usually has 15 seats. A sub 3, or the third row, has 19 seats in it. So what's happening every time? We're adding 4 every time. Okay, so does that make it arithmetic? Sure. Let's say there is 23 rows. How many seats are in the 23rd row? What you giggling about, Willis? You just blinked a lot. My son got a Nerf gun for religious day Easter. I don't know what the heck to call that one. Did you draw a picture? You guys are horrible. His tree, I like his better. His is a conifer. Okay, so notice we are increasing by 4n. Now to me, whenever I have a sub 1, I personally just subtract my rate. So that's going to be 7 for a sub 0. Would you guys agree? Yes? So there is my generic equation. But is that what I'm asking for this time? What am I asking for? I am looking how many seats are in a sub 23, right? So what would I do? I'd replace the n with 23. So I have 4 times 23 plus 7. So that's 92 plus 7, which is 99 seats. Do I got a second on that? Somebody else get the same result as I did? Does anybody have any questions about how you might go about an arithmetic sequence, how you could find a generic term? Pretty simple, right? Because it's all about linear, which you've studied before. Okay? Now, just like last lesson, we also learned how to do the sum of a geometric. Okay? Well, there was a famous mathematician, I can't remember, it might have been Gauss. Okay? His teacher, he went to school, and back in the day, school was a privilege, not everybody went, right? And he went to school, and his teacher, I guess, was having a bad day or whatever, and it's like, hey, I want you to find the sum of the first 100 numbers. the teacher thought it might take him a good half hour to an hour. Okay? Was that good? Oh, is that the blue? In the blue and the red, you can't see that one? Hold on, hold on, hold on, hold on. I'm gonna hook you up, brother. Watch what I'm gonna do for you. 1 plus 2 plus 3 plus dot 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 plus 98 plus 99 plus 100. So what happens is the mathematician, he became a famous mathematician later, but he was really young. The guy thought it would take him about a half hour to an hour to add up all these numbers, right? Okay. He comes back in 3 minutes, says, I got your number. And the teacher's like, what? Come on now. And he's like, okay, show me how you got the number. And he got the number right. So the teacher's like, okay, show me how you do it. Does anybody have an idea how they might have did this in only 3 minutes? Go ahead. Very close. You're very close. You're actually going to take 1 and 100. What does that always add up to be? 101. What does 2 and 99 add up to be? 101. What does 3 and 98 add up to be? Okay, how many of those are we going to have? Why 50? Can you explain 50? There's 100 numbers and we're pairing them up in groups of 2, aren't we? Pairs? Yes? So therefore, I have 50 numbers, 50 of those of 101. So he comes up and says that's basically, what do we got? 0, 50, 50, I think? Is that what it is? Somebody here and put that in? I think that's what it ends up being. Yeah? Okay, so 50-50. He came up with that number. And just like Tyler just did there, his thought process was, let's add these together. 1 plus 99 is 100. 2 plus 98 is so forth. But that means that I would have an extra 100, right? And then I'd just have the 50 because his buddy would not. He would be by himself. Does everybody see what he did there? Okay. So let's go ahead and write it in a generic form, though. So really, what did the guy do? He took the first term and did what? He added to how many? To the very last term. How do I write the last term? In our case, it was 100, but in general case, I do a sub n, meaning the final term, right? Okay. And then where did we get our 50 from? He did the number of numbers there were. What could we say that would be? N, because if this is like the 100th term, then this would be 100, wouldn't it? Does that make sense? Over 2, because he's putting them in pairs, is the sum of that sequence. This is something you will have to memorize for your test. But hopefully the story can somewhat help you in what he did. Okay, adding the first term, the last term, okay, and telling however many number of the terms and divided by 2. Any color? Yes, you can. I believe it. They want his dirty hands. Okay. You guys ready for the next example? What the hell? Hell. Somewhat. It's up to him. It's his. That time I did. That one almost took my. Whoa, that's high. I'm spinning. Oh. Oh. Okay. Thanks, Steve. Woo. Oh, man. Okay, wow. Here is our next problem. 3, 7, 11, 15. Dot, 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 dot. Excuse me, I'm putting plus signs in between these because we're finding the sum. Plus a sub 40. So all the way to the 40th term. Do I know what the 40th term is? What do you guys think I need to do first? Find the 40th term. But I want to do the sum. How are you first off? Okay, let's go through the steps. First, find a sub 40. How am I going to do so? I need to find a sub n. The generic form, right? If we find the generic form, could I plug in n for 40 or 40n for n and go back and find it? Sure, and then after that, then I'm going to find the sum. No? Oh, okay. So I asked Sander. Sander said it's increasing by 4, so therefore that's our common difference times n. Because I have my first term, I can go back 4, which would be -1, which would be a sub 0, right? Now understand, though, I'm only using for my sum, okay, I'm only using for my sum these first 40 terms, though, correct? Okay, so therefore this would be -1. So what is a sub 40? A sub 40 would be 159. Does everybody understand how I got 159? Any questions on that? Then, to find the sum of the first 40 terms, I would say, okay, there are 40 terms. I'm going to divide that by 2. I'm going to times that by the sum of the first number. What is the first number? 3 plus what's our last number? The 40th term, which was 159. Yep, because of the pairs. Remember how we talked about you're grabbing the first one and the last one, so there's then going to be only 20 of these combinations. Does that make sense, Thane? Okay. Now what if the black went into the blue? So this is 20 times 162, which is 0, 4, 2, 3,240. So 3,240. That'd be the sum of the first ones. Okay, let's go back to our problem with the rows. There's some people that have issues. If you were ordering at Chubby's, what would you get? Serially? The most basic burger there is? He does every day. He works there. Well, there is I make fry sauce at home and it doesn't even taste close to a restaurant. I don't have the right combination. Mustard? You're throwing mustard in? Some people put in a little pickle juice. That's what I'm saying. Holy shnikers. Okay, how much did row number 1 have? It was row number 1 of the auditorium had 11 seats, right? And then row 2 had 15. Row 3 had 19. And we actually found row 23, did we not? And it had how many? How many seats can this auditorium hold? You're wrong. How many seats could this auditorium hold? Why are you moving? That was a delayed reaction. When are you going to become an EMT? Have you already got jobs lined up? Watching you, Gregory. You're going to try to swerve it. Where did it go? Did it go out? Did it hit you? What you talking about, Willis? Okay, guess I can hold it then. So, what did we get for the first 23 rows? The sum of the first 23 rows was 23 divided by 2. Now, this time it didn't go in nicely, did it? Which is okay, which is all right. And then I had 99. Excuse me, hold on. Let me do it in a common way. 11 was our first row. We added it to our last row. So we got 110 as our sum, right? Times that by 23 divided by 2. Or that is 55 times by 23, because I just divided by 2. Which is 1100 plus 165. Did you guys get 1,265 when you times those two numbers together? Geometry. Okay, let's see. I think that's it. That's it. We still got a half hour. So, hey, meanie heads. So, we are going to start. Whoa. Hold on. One more. That is the deal. I will get this done. It's just one more example of this. I want to find that sum. Because as soon as you see the sigma, that represents the sum anyway, doesn't it? He took one in the arm for you. Give you a oh, luckily I was out. Okay, how do I do this problem? So it's already telling us the sum. What term is our beginning term? We don't start with 1 this time, do we? So how many terms are there from 3 to 10? 7. There's actually 8. Let's count them. Ready? 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. Just think about numbers 1 to 10. If I put 1 here to 10, how many numbers are there? 10. Because 1 to 10 is 10 numbers. If I went 0 to 10, how many numbers are there? 11. My trick is subtract them, then add 1. So I would subtract, then add 1. And that tells you the number of terms. Okay? So we have 8 terms. What's our beginning term? Well, excuse me, this should be n instead of k. So n is 3. I plug it in. Our beginning term is 7, is it not? 2 times 3 is 6. 6 plus 1 is 7. Okay? Once again, plugging 3 in for n. Maddie. 2 times 3. 6 plus the 1. What's our last term? I'm going to plug in 10 for n. 2 times 10, 20. 20 plus 1, 21. So this is 4 times 28, which is a lovely, lovely 112. 8 divided by 2. Because remember, how many terms are there? 8 of them, and remember we group them by pairs, so there's 4 different pairs. Remember that? Notice, guys, I'm going to show you on my calculator. You could actually do this on your calculator if you were able to use this, but you guys aren't. There it is. Okay, hold on. I had to figure out where it was again. So if you guys look down here, the summation one, number 2. So I just put in x equals 3 to 8. And was it 2x plus 3 or plus 1? What was on your paper? 2x plus 1? 2n plus 1, but we're going to do x instead. Uh-oh. Oh, I went to 10, huh? That makes a difference, not 8. $112. Okay? That is now the last of our lesson. You guys are doing 1 through 53. EOO. Then you're doing 62, 64, sorry that they're evens, and 67. This is on the 12-2. Once again, this is the minimum standard. You can always do more, right? Okay, thank you much. Here's your lesson.